front.
Arigato, konnichiwa. So my Japanese is not as good, so this talk will be in English, but I will try to go to be as understandable as possible, but feel free to take me aside if you want me to go slower. So, my name is Vladimir de Turckheim. I'm the lead Node.js engineer at Screen, which is a startup based in San Francisco and Paris, France. That's where my accent is from. But also, I'm part of the Node.js Foundation. I'm a Node.js collaborator, but I'm mostly part of the Node.js security working group, meaning that if you have concerns or questions regarding Node.js security or the ecosystem security, feel free to contact me. I will be more than happy to help you and give you directions. You can follow me on Twitter. I'm at PaulDefet, which is a pen that only works in French. Or feel free to email me at screen.io. And today, this morning, this talk will be a story time. So lay back, enjoy the talk. It will be a trip together. And also, I'm telling you right now, the last slides will contain a link to the presentation. So feel free to not take too much notes. If you want to get the slides, you will have that in 30 minutes. Okay, this story starts in June 2016. I just joined Screen. Screen is a small company, it's a bit young already, but there is a piece of code that's already there. Screen is a security company, and this piece of code is used to detect SQL injections. And it's written in JavaScript, it runs into our JavaScript applications, I mean, one of our clients. It runs into our client's Ruby application, it runs into our client's Python applications. And it runs one time, each time there is a SQL query. Each time you do a query to Postgre, MongoDB, or SQLite, or Oracle, this code has to run. And the question was, hey Vlad, we think it's slow. Can you take a look? And I'm just 24, and I just joined this company, and they've got their very big piece of code, it's thousands of lines. And they tell me, make it faster, please. I'm like, how slow is it? And it was 5 milliseconds per execution in average, which is extremely slow compared to what it's supposed to do. And once again, it runs each time there is a call to a database. And I was like, sure, but this code is a black box for me. I don't know anything about it. And I don't have time to load it up because you gave me other tasks to do in parallel. So I will look at the code overall and I will check what I can do. And then there was a third thing I saw. So the code is a function named isSQLinjection, defined on line 1. And as you can see on line 2 and line 5, there are some other functions defined into this main function. They are closures. Which means each time you call isSQLinjection, each time you call the main function, the other ones are redefined from scratch. Thanks a lot. Are instantiated in memory. And that takes time because the engine has to go through the whole code and instantiate it and create the variables, create the function, and that happens each time you call the function. So I did a simple thing. I removed the closures because it was removable, and I outlined other functions. And as a result, the code gets much better. I divided by 5 the execution time of the code because you had to instantiate so much code, it was terrible. So I was happy, and that was September 2016. But then, a few months later, GB, my CTO, came back and told me, hey, I think we can make it faster. And now Screen is growing at this point, and we've got a lot of clients. I mean a lot. A few more clients. And they come to us with new inputs that makes the code slow. So we had a better test bench. So he told me, yeah, can you go for it? I was like, yeah, but I did the biggest quick win, so now I need to go one level down and to see what is in the code. And I discovered that the code was basically divided into 3 main parts. You had prechecks, you had a method named parseSQL, and you had a method named detect. And I put timers, and what I realized is that the slowest part was the parseSQL part. So it was 100 times slower than the 2 other parts. So it was evident for me that it was where I will have the quickest win in optimization. So I went for it, and the question is, what does this function do? Because at this point, I cannot just look at the code as a black box. I need to optimize the algorithm itself. I need to understand what's under the hood at this part. So I go down one level, but first of all, I will explain you what is the goal of this function. Let's say you've got a SQL query, select star from post where ID equals 1. This SQL query can be divided into different tokens, different words. You can understand the sentence, meaning that you've got one token for select, one for star, etc. So that's the first thing the function does. And then it goes through each of the tokens and gives a type to them, meaning that's a SQL command, that's a list of columns, that's another SQL command, that's a table name, that's a command, that's a column, that's an equal, and that's a 1. That's a literal. And that's exactly what this code does. So let's see what does the code look like. So we've got this function named parseSQL. It takes SQL code as arguments, and what it does is instantiate a new parser and returns the result of parse. So, and as you can see on line 8, it's called by SQL injection. So my question was, hey, what does the parser do? I need to understand that. So the parser basically has an infinite loop that stops when there is no tokens to find anymore. So tokens are the name of each the element of the SQL query. Select is a token, star is a token, from is a token. And while there is a next token, it will pass it and add it into a list, and then return the list. Okay, so how does it pass it? So the parse function is actually way longer, and that's just a sneak peek of the content. So let's go through this function starting at line 7. On line 8, you check if this.peak3 is hashtag greater than. So this.peaks means, in that context, it's an NPM library who provides this method, means what are the next 3 characters in the SQL query. So you are passing the SQL queries from left to right. And at one point you say, what are the next 3 characters? Gives me a string with the next 3 characters. That's what peak does. You check if that hashtag greater than, which is a Postgre operator when you handle JSON data. It's specific to Postgre. And if you find this token, you save its location, you move your cursor 3 characters on the right-hand side, because you need to go further in the string, and you return a new token with its value, its type, and its starting position. But if you haven't found this one, maybe you can try for an equal. So you do peak 1, because equal is only 1 character long, and you return a new token if you find that, and of course you move the cursor and keep the position. And the thing is, this is far more used, equals is a symbol far more used than hashtag greater than in SQL. It's like equals happens in every other SQL query. People handling JSON SQL are more rare, and they're only using Postgre. Meaning that we were checking first for things that are unlikely to happen. And if you start to check first for things that are likely to happen, you are likely to stop quickly to test. If you test first for equals, you are more likely, because you are more likely to find an equal symbol in a SQL query, you can get out of the function faster. So I went through the whole function, and for each potential token, I checked their popularity in the SQL language, how likely they are to be there. And I ran them in that direction, meaning now the function will exit earlier because it will be more likely to find tokens quickly. And that was much better. We divided the execution time by 2 by doing that. We were happy, and it was August 2016. Clients were happy, employers were happy, I was happy, it was sunny. So, but you know the story. Once again, my boss came at me and told me, hey, there is a new thing. And we've got that client who performs approximately 100 SQL code per HTTP request. Remember, this algorithm runs 1 time each time there is a SQL query, meaning this time it ran 100 times per HTTP request. So it slowed down the application of the client. We used to say that we don't slow down your application more than 10%. And that was more than 10%. So we had to reduce the execution time of the code. So once again, I went to that and I was like, ParseSQL is still the slowest part. So let's go back to ParseSQL. So I looked at the code. You see that the updated code we changed in the previous iteration. And what does peak do? I mean, as I told you, it comes from my npm module. I had a bit of a hard time explaining you what it does. So maybe we should go and check what's the code of this peak function. And that's basically a slice. It does a slice, it starts at the current cursor position, and then it stops at the current cursor position plus the offset. Okay, okay. Is that efficient? No, it's not. Because when you do a slice in JavaScript, you create a new string. What does that mean, creating a new string? It means that the JavaScript engine has to find a memory space to put this string. Then it has to write the string into that memory space. Then it has to distribute reference pointers to that string. Then it needs to tell the garbage collector that there is a new string somewhere it should look at. And since we created one string per check, it was extremely slow. So I created another function named scanstr. This function basically takes a pattern directly, and it checks characters by characters if the position currently on the SQL query corresponds to the patterns. Is the cursor starting with the same thing as the pattern? Yes, no. Is the second character the same? Yes, no. Is the third? And there is an early abort. Each time we find a difference, we go out. And actually, that's much faster than creating a new string and comparing strings, because you're just comparing strings here. And you're not comparing them all the way, you're comparing them lazily. So it was pretty fast. How fast, you ask? So yeah, of course, I had to change the code of peak, the code here, and I removed all the peak by scan string and the token. And I even find it more readable, because you know I'm just saying, is the next token that, instead of things, are the three next characters this token. But that's side bonus, right? Are you happy with that? So, once again, that's much better, you know, history is always a loop. So, it's March 2018, the code is blazing fast, it takes less than 1 millisecond to run, a fifth of a millisecond to be honest. And I was happy, it was a long week. I don't know if you realized, but the first thing was a quick win, the second one was a not so quick win, this was not a quick win at all. And now, my boss tells me, hey, we got rid of one of the dependency of the Ruby racer, meaning that all this code will always be running on V8. V8 is the JavaScript engine that runs node.js and Chrome. So you're using Chrome, you're using V8. You're using Node, you're using V8. And we got rid of another engine named Ducktape, that is pretty slow. So I was like, great, I will use my knowledge of V8 to use some cryptic stuff I know about it, and nobody else does. No, come on, I assume some of people here know what I will talk about. And you have to know that V8 is a bit opinionated. It's a great piece of software, I love it, and V8 loves types. Oh, but JavaScript is not typed, right? So how does that work? Let's see, I've got this function named addThings. It's a simple function. On line 2, as you can see, just do a plus b with a and b being the parameters. And since, why not, let's run this function 10 power 5 times, a lot. And with integers as arguments, I and I plus 1, sorry, is in French. But I will run it with special parameters in Node. I will use the --trace opt function with a flag. What does it do? It tells V8, hey, tell me what you do to optimize the code under the hood. Tell me what you do, I want to understand. And you've got some terrible logs, but if you take time to look at them, I highlight what we want to see. Marking JS function for optimized recompilation because it's small and I have type infos. What does that mean? That means that each time you're running JavaScript in V8, there is a little spy who is looking at your code. And this little spy is like, this function seems to take always a number as first argument, a number as second argument, and returns a number. Meaning I can optimize the code to be like that, because it's a numeric function. So this little spy just do that, and it optimizes the code. And then V8 optimizes the code, meaning it recompiles the code directly in assembly. And that's blazing fast. That's why V8 is one of the fastest JavaScript engines around. But what if the signature that has been optimized changes? What happens in that case? Then, let's do a test then. So, as you can see, we've got the same code from line 1 to 7, but then, starting line 8, I put another loop, but instead of giving two integers, I gave a string and integers. You see, the first parameter is casted at string with a plus quote quote. Okay, and I added another flag to the execution. This other flag was trace deopt, which, as its name announced, will trace the de-optimization of the code. And we read the same first line, the same one optimizing the function, but what interests us is the last one. De-optimizing insufficient type feedback, meaning that V8 saw that its optimization was not good enough and had to remove it. Each time there is an optimization or de-optimization, you actually lose performance in the JavaScript engine. So how does that work for our little spy? We all love it. We all love it. And the spy says, okay, at line 6, I'm under the impression that the function is number, and returns a number. So I will optimize for this. But at line 9, it seems that the function now has the signature string, number, and returns a string. My optimization is terrible, I can't use it anymore, so I need to remove it. But, I mean, can't V8 just re-optimize the function later with the new signature? Why not? So V8 just says, now the function has the signature string or number, and returns a string or number. And it will re-optimize the code. So if we go back to the optimization log, we can see on the last line, marking function for optimized recompilation with a small function with type info. And that's pretty good. But we are engineers, right? We love to mess with things. So what happens if you give another type again in a third loop? As you can see on line 12, we are giving a string and an object. And then the spy is like, I give up. Come on, that's sick. I don't want to handle this code anymore. So at one point, the spy will give up on optimizing your code if it happens too much that it optimizes, de-optimize, optimize, de-optimize. The V8 team has a name for that. It's called de-optimization hell. So the spy just says, I give up, that's your code, it's slow, that's not my problem anymore. And you don't want that, you want to keep your code as fast as possible. And wait, there is more. So maybe the solution would be to always use objects, right? That's always the same type, but it's not. So V8 has a concept named shadow classes, meaning each time you create an object, V8 will create what it calls a shadow class. And that will be the type of the object, meaning that you've got numbers, you've got strings, and you've got a type per shape of object you create. What does it look like? That's another function, do things, but we don't really mind, we don't really care about what it does. What interests us is what gets in. At line 6, I gave it an object with a value, a key A, and a value that is a number, which is, this is a shadow class. It has a shadow class. Shadow class is object with a key named A, a value that is a number, and no other field. That's the shadow class associated with the argument on line 6. And as you can see on line 9, the shadow class is not the same, because it's a shadow class of an object which has a property named B and a value that is a number. So for V8, that's two different types. It will not give you the straightforward optimization, and you will have an optimization, de-optimization, re-optimization cycle, as if you were using numbers and strings. So you need to check closely what your function are used with. And the game was really slow, because remember the previous game, the previous value here was 0.20, and now it's 0.17. So I spent weeks optimizing code for having better typing and other V8 gotchas, and I did not get really anything out of it. That might even be a major artifact. That might even be maybe a major error. So let's wrap up, and I have a few advice that I learned during those 2.5 years regarding how to optimize code smartly. First of all, use the tools. I haven't shown you the use of the tools in this talk, but if you want to know how your code is behaving, you have to use the Chrome Dev tool. One of them is the CPU profiler that will tell you how much time your code spends on some pieces of it, so you can identify bottlenecks. The other one is the heap profiler that will tell you what does the memory of your code looks like. What are the objects that takes more memory, what are the objects that takes less memory. And that's really important, especially when you do front-end stuff, because you don't want to bloat the memory of your users in their web browser, otherwise everything will get slow, there will be a lot of garbage collection, and your user experience will be terrible. So use the tools to profile CPU and memory. Don't premature optimize. First of all, you will waste your energy, and you will not go in the right direction. Only optimize when you've got a need for optimizing, because this need will drive what you want to optimize. Let's say I optimized without any real-life SQL queries, I wouldn't have optimized the real part of the code. I wouldn't have found the issue with the orders of the check we did at the second part. So optimize based on your need, because that will drive you to the goal, and that's what you want to do. You don't want to optimize a void function, the spherical function in the void. Do not waste your energy. Again, start with the easy part, especially when that's a big piece of code, especially when you're not leveled up on it. Start with the easy part. First of all, you will level up on this piece of code. You will gain trust from your employers and clients because you will get quick wins, and you will get self-confident on this piece of code. Don't try to do perfect on first time because it's extremely hard. So do efficient and protect yourself. Find the bottleneck and focus on them. It's finding the quick wins. It's finding what will be the reward, what will make the most sense. Maybe the other functions in the code were slow, but the one I optimized was the slowest. That's why I had a gain, that's why I created a business value for my customers. Do not lose context. Everything you do, you have to do for a reason. Otherwise, you will just spend time doing things that are not extremely important. Do not lose context, do not lose the big picture. What is the goal of your app? Is it the best use of my time? Because that can be extremely time-consuming, and I won't lie, it's extremely fun to go deep in how V8 works and try to understand and reverse the magic. But at the end of the day, you don't want to waste time because that's time you could have spent building an amazing product. So don't lose context and always look at the big picture. Thanks so much for your attention. Arigatou gozaimasu. I will ask you, if you can, to go on that URL to give me feedback about my talk. I would really love that. It was the first time I gave it, and I want to improve it for the next times. Also, as promised, on the right-hand side, you've got a QR code and a link. So take it if you want to keep the slides, and you can directly email me or ping me on Twitter if you've got comments. I'm here for the whole weekend, and thanks again for your attention.
Hi, ありがとうございます。じゃあ